everybody. Thank you for tuning into this super special episode of What's New in Data. We're live here at the new Striim headquarters on Emerson Street in Palo Alto. It's a fun fact. It's used to be one of the original offices for Facebook in their early days. There was, in fact, a Facebook server in the room here. But what I'm more excited about is catching up with Alok Pareek here. Alok is a longtime executive in the database industry, and he's a co-founder of Striim. Alok, how are you doing today?
Doing terrific. Thank you for having me, John. It's a pleasure. I've been meaning to come to one of these famous podcasts that you do. So excited to be here today.
Yeah, absolutely. And I'm equally excited. I've always wanted to catch up with you. And in this forum, we always talk whiteboard, technical ideas and architectures, but I've never just openly talked to you about your experience in databases, which is just incredible and super interesting. All the collective knowledge you've gained throughout the decades, and you're really one of the leading minds on this topic. So, but I want to open it up to you to just tell the listeners about yourself.
Sure. So I can get started. And of course, that shows my age too, that I've been around in the database industry a while. Um, so started my career in the Oracle database team, which is a fascinating experience. So this was right after my grad school. I did some work at Stanford. In fact, Hector, God bless him, I worked with him as his TA. And so he was sort of a heavyweight in transaction processing, taught me a lot, told me to keep things simple, always told me about some of the hard problems in industry, which I'm hoping to share with you. Yeah, so I started my career at Oracle, which was a fascinating journey for 10 years. And it was a really good program. So they sort of had this amazing program where I got to be part of different teams. Believe it or not, I've actually got up at 5 in the morning and listened to Oracle support calls with some really amazing Oracle people like Sher Yamaguchi and these guys who are responsible for some of the core practical ultra large database implementations in the world on the maximum availability architecture. Then a little bit of consulting as part of still being sort of in the database side, a little bit of consulting where there were always these firefights between, sometimes support would have an issue and then development would take some time to kind of navigate that. And so there was this kind of a rapid team called React. I don't know if I remember I think it was called RDBMS, escalation and activation team or something like that. And so there were, these people who actually also were programmers and could understand support issues and respond to customers quickly. So got to experience that. And then I learned that, most at that time, kind of the hardest area that a lot of people used to face challenges in was, database would crash or they would lose a file or they'd have some sort of a disk corruption. So that kind of attracted me to sort of recovery and self-healing systems and things like that. And that's when I sort of, went into the recovery team, spent close to 10 years there. So this is kind of the core area of, crash recovery and media recovery in databases. So that's kind of like how I got my career started. And then I went on to, other things like Golden Gate and eventually up to Striim.
Nowadays, Oracle is a household name in data and AI. You can't go to CNBC.com without seeing an article about Oracle stock or Larry Ellison, and even the new stuff they're doing with AI, even collaborating with OpenAI through their latest projects. But in the generation you started there, it was still very much a competitive and open market. So the work you were doing really led to their market dominance, which is pretty incredible to hear about how you worked back then. And I wanted to get into one aspect that you mentioned to me, which is, now we have this definition of big data, which is terabytes and petabytes of data. You were working on one of the early big data projects with, let's say, roughly a terabyte of data in a transaction processing system. We'd love to hear about that.
Sure. Yeah, that's a fun story. So, when I joined, I think, it was probably early versions of 6, I think, late 5, early 6. And, and then, obviously the way the database development team was working, we were working on 7 also, because that's usually a few years ahead. And at that time, there was an initiative to try and sort of have like a very large 1 terabyte database between HP and EMC and Oracle. And so it was interesting. So there's a bunch of engineers from HP and Oracle, and we all actually flew to EMC, which was in Massachusetts. And I mean, I still remember it very vividly. It was a huge kind of a warehouse type of setup, and there was just like literally disk drives like sprawled all over. Right at that time, disks were big, and there were cables all around. And so a number of folks that went from Oracle and also from HP, we literally just went in there and had to hook up servers and disks and and the cables. And prepared sort of like the Oracle database. Now, what was interesting about that was at that time loading 1 terabyte was kind of a crazy concept, right? So we had to figure out things like how are we going to load these things in a reasonable amount of time, and so that led to a bunch of work, including direct path loading, where you could bypass kind of some of the logging concepts and etc. Efficient indexing around that. We also had to like lay out sort of the data on literally different disks, right? So there's no contention. This stuff is classic now, right? There's no contention between your actual data blocks and your index blocks. Literally just physically at a file level, at a disk level. And then we published that. I don't know. This was pre-internet, I think. So I know that white paper is available somewhere, but I don't know if it's available in the public arena or not. But yeah, it was very exciting to kind of declare victory on kind of like a 1 terabyte database collaboration between kind of EMC, HP, and Oracle.
Yeah, that's super cool. And you mentioned some of the contention between the indexing versus the storage level and the read level. Can you get into some of the technical trade-offs you had to make there?
Yeah. So, I mean, typically, like, I mean, ultimately, at that time, now this technology has also advanced, though still continues to still bottleneck to a certain degree. But at that time, if you talk about just hard disk drives, I mean, ultimately there's an arm, right? There's got to move. So your seek time, sort of, you have to pay that penalty. So if let's say you're trying to go through the optimizer and you try to look up something. So you gotta like, go through your B tree or whatever the variant might be, maybe a hash index. So you have to go fetch the kind of the root blocks there and the index block and then the data block. So if they're all on the same drive, then you can't quite, to a certain degree, there's a queuing that gets involved there. So to try to actually just keep them on different disks was kind of a classic technique that was used, right? We would say, okay, let's separate even our like, you know, um, log files would be on a separate disk than the data files, for example, and then between the data files, if you had different applications and trying to actually also keep those separate from a and broader sort of maybe a container level like a table space, for example. So those were some of the techniques that we used to kind of really be gentle to the optimizer, so to speak.
Yeah, absolutely. And this was very much early days for those types of workloads. So ingesting a terabyte of data at that time was considered on the kind of the extreme end of performance requirements. So have you seen any of that, any adoption of those techniques in like more recent storage engines?
Yeah, I mean, I mean nowadays, again, like so there's several ways. See, ultimately, the problem of just sort of doing fast loading comes down to, can you partition the data set, number one, right? So if you can partition the data set, then it's just a number of like how many threads, so to speak, how many cores you want to actually go through at that problem, and you can actually go load that super fast. Now, what's interesting there is, um, you know when you do these massive loads, what happens to also kind of the indexing, right? So it's kind of inefficient to build the index as you are going along loading the data as well. Your tree gets queued and whatnot, right? So and I think that's pretty much common now, right? Where you could actually do things like direct loads and then build an index after the load itself, so that now you kind of have you can take a pass at all the data, so your keys are sort of like more well organized, and you're not sort of doing random seeks all over the place. So yeah, that are the early techniques that we had, and I can just specifically tell you in Oracle for sure we had this client utility called SQL Loader, and in SQL Loader, we still run into some of these issues by the way even today, where we evolved it. I mean, number of developers were involved, but to try and say, hey, I'm going to actually do sort of a insert directly in place. So let's say if you have a table which has a bunch of blocks, the blocks are on some free list. So you grab a free list and say, okay, I'm going to insert it in there, right? And so that's an in-place insert. But a faster way was, well, let's just go and see what is the high watermark of this table at a segment level, and then just go ahead and just start shunting all the bytes there. The advantage there, John, was then if you died in between, you could just do one simple undo of the whole thing, right? But if you imagine if you actually did a direct place insert, imagine that I have 10,000 blocks to write, hypothetically. And if I'm going into different areas on disk, then if I have to undo it, I got to go to each one of those blocks all over again and undo that, right? So all of a sudden, then there's implications in terms of the not just the forward-going load performance, but also because if it's a direct path load, you could write it contiguously. But if you have to go in place, then you have to go in specifically to locations, and that's inefficient. And then not to mention that if something goes wrong, to recover from it would be super fast, right? So those are some of the techniques which I think now they're mainstream. Although I would still say I still get surprised that not all systems have it.
Yeah, and that's some of the fun work we do here at Striim is we're constantly evaluating the new popular up and coming architectures. Whether it's the hyperscaler cloud storage engines like S3 and GCS and whatnot, where they sort of abstract a lot of that from you, and then you have these new kind of data lakes, which whether it's Delta or Iceberg, which have their own approach. And for instance, in Iceberg, you have to pretty much manage the write process yourself. I mean, it's great for reads and managing tables at scale across object storage. But some of the surprising stuff that we come across where you sort of have to build this stuff again, right? And take a pass at it as if it's a nascent area to do development. But one of the things that you touched on in your description was the recovery process and the logging process. So you've always had a lot of experience in that area. I'd love to hear kind of your perspectives on your experience with recovery and how it's evolved over the years.
Yeah, yeah. So recovery is definitely close to my heart. I mean, I spent a lot of years in database recovery. So in Oracle earlier on, I used to own these. There's one component called LogWriter, and at the time I think I joined Oracle, there was only I want to say there was like only 5 kind of these main background processes. It's just this is a C code base, and one of them was LogWriter, along with like database writer and checkpointer and system monitor and process monitor, etc. So when I took that over, so the interesting thing there was you know logging was this one thing which made things really fast, right? Like I mean, if you just imagine if you didn't have logging, then obviously you have to go back and do, for every commit, you'd have to go in and really update the in-place table records, right? Just imagine if I touch like 10 records, then I have to go in and make sure that as part of my commit, I flush all those blocks to disk. And so logging is sort of like this, and some of this is like has been around for a while since the Aries system. But you're doing sequential write ahead logging to kind of just effectively be super fast and efficient in your commit path, right? So I go touch a bunch of stuff. It allows me to go and dirty a bunch of blocks, and then in one operation in the log, I can go in and commit or undo my work. It also allows you to just steal dirty buffers before commit, so that alleviates the memory pressure. So this area was really interesting, and partly, I was actually more interested in recovery because customers would really struggle with this thing, right? So just to give you an idea, John, like imagine that you have like, I don't know, 200 files that make up your database, right? And they're sitting on like, 10 disks. So you have all these files, then you have your logs, and then you have like the metadata, which is your catalog and your dictionary. And you'd get into these funky scenarios where someone would be like, oh, my database is not coming up, right? And you're getting some errors. So there is an amazing dance between the metadata between these files and the log and kind of the metadata, which is the like in what was kind of the control file, where we would keep the appropriate metadata to know what is the state of this thing, right? So very earlier on, I used to just love that you could manipulate like a few bytes here and there in just like one file in its header, and it could be sometimes you just get corrupted because of just magnets, right? I mean, disks are ultimately magnetic, and things would go wrong. So what would happen is, the DBAs would try something. They would like try to recover this thing by saying, okay, I think that file is corrupted, so let me go to my backup that I made 2 weeks ago, slap on that file, and then, it would still not work sometimes. So then it almost became this amazing thing where these recovery developers were like brain surgeons trying to figure out what is going on with this entire recovery. And you would find out that when during the backup was taken perhaps inappropriately, and so it's like not a proper backup where you have to go through some proper steps and so forth. And so I learned that, forward going in recovery, you have to throw enough stuff so that when things really go bad, you're able to recreate a picture of what's going on. So looking at a state and then saying, how did I get there? And so I've always in my head always maintained that, even during my career in recovery at Oracle, and then moving on to replication and streaming and then AI and so forth, right? There's these things are sort of all, the log is sort of like an interesting thing that kind of is a unifying framework to me across a bunch of this work that I've done till now.
Yeah, absolutely. And we can touch on all the reasons why it's technically crucial to have logging in your database for recovery purposes. I'm just going to jump to the other end of the spectrum. What happens if you just don't run your database with logging? Where are the risks? How will it operate? What does it actually mean for the business users of the database?
Yeah, so I mean, and in fact, I can, depending on the definition of the database, there are many databases that, in fact, don't run with logging, right? I mean, if you take a look at even, especially analytic systems, right? Logging might be a big overhead just because you're doing massive parallel loads, and there's no point in maybe logging all of that stuff. So what you do there is like, you run this thing and then you just take another backup, right? So now you're moving at basically your, so in fact, what the log does is it spreads out like your state evolution, right? So each change vector can take you from one state to another. And then if you sort of, bypass logging, now you're going through sort of, from one jump of a state to another jump of a state to another jump of a state. So you just have to be methodical about that and be aware that your specific the state to which you can recover is not going to be the most recent state. You might have work that's lost since the last time you took that backup, which may or may not be okay for your specific workload. And also, like I mentioned, if it's an operational database, then I think if you bypass logging, you will find that your actual IO is going to just be not it's going to be start interfering, right? You won't be able to get as much throughput. Like I mentioned earlier, if I go in and for every single transaction, let's say my transaction has 4 actions and it's touching different tables, that means that I need to go now write to 4 different specific locations on disk. And now, depending on again the disk type and whatnot, I may have to like pay that my time for random access to that specific block on disk, which kind of logging obviously is good, right? I have a sequential point and I just have to I already have my specific I've already sought to the specific sector, and now I'm basically just seek time and rotational latency are hardly there's
So it really does have impacts on the operational side of the database, not just recovery.
absolutely, absolutely, yeah. I mean, I think I mean, just imagine, right? Like if you're doing work and if I want to commit, and let's say I just touch like, just hypothetically speaking, I just updated every single record in my table, and let's say I'm a customer like a large financial application, let's say PayPal or a Square, right? So I might have like 100 million users. That means I need to go and update 100 million locations on disk, right? So what I want to do is I want to be able to actually go in and in my memory go dirty or change all these buffers. But then if at the time of hitting commit, instead of me as a client just waiting around for flushing all those blocks, I just have like one write to the log, right? And I'm done. And lazily now the in the database, the flushing can happen lazily, based on your LRU schemes and whatnot, right? So that's kind of the optimization there.
Yeah, and your work obviously evolved from working on the log writer of the database to Golden Gate, and just for a bit of context for the listeners, Golden Gate is I'll let you describe Golden Gate, but logging in general, I mean, for instance, it's received a lot of attention from the leaders in the industry, and those who actually adopt and run these massive big data processing and distributed systems products. For instance, Jay Krebs, the co-founder of Confluent, was famously infatuated with your work at Golden Gate. He wrote about it even before he started Confluent, right? And but that's just one example. I mean, there's many examples of how logging's been deployed as this kind of, like you said, it's a a unifying concept for kind of journaling the state of an application. So I touched on Golden Gate. Would love to hear about your experience there.
Yeah, so John, Jim Ray famously used to say the log knows everything. In fact, I did meet Jim one time at a VLDB, but that's a separate story. Um, so let me kind of tell you how I got interested in Golden Gate. So if you take a look at the use of a log from backup recovery, very quickly for certain replication techniques, but there's been a lot of research in this area over the years, over the decades. But very famously, Pat Helland and Jim Gray talked about kind of some of the evils of replication very earlier on. And they used to talk about, like, one of the classic techniques obviously is lazy replication. And in lazy replication, you can use the log to make it available to sort of, not just the node that's generating the transaction, but also to other nodes. And you can kind of catch them up using the log, right? So replication was so rather than do eager replication where you're replaying the same action at multiple, sites, you just say, hey, I'm going to just do it, harden the commit on one, and then I'm going to asynchronously propagate it lazily. So that was a classic technique in replication. And at that time when I was at Oracle, this was also used for data protection for things like standby databases, and led to eventually products like DataGuard and whatnot. But the evolution at Golden Gate that was sort of very interesting was the heterogeneous application of logging onto just a completely separate system. And so the idea there was that I may be originating my transaction on maybe a specific database vendor, MySQL, Postgres, Oracle, but I want to replay that transaction logically onto just a completely separate vendor stack. And so that's the problem that Golden Gate very successfully solved. And it became very, obviously, sort of state of the art. And so the application of it then, speaking of replication, so both to, number one, just availability. So from ATM networks, there may be banking applications that might be running against an ATM, and so you want to do high availability for the ATM. So replication based on Golden Gate became like a really interesting technique to solve that problem. And the second one was performance, to scale out a workload. With the dawn of the internet era, there was a lot of work around, hey, how do we scale these systems? Because the number of subscribers or users that are coming onto the system were orders of magnitude higher, right? I mean, earlier, for example, you might have maybe hundreds of travel agents doing something. Now, with you and me logging on and trying to search for fares, that number just became, million or higher. So the choices there for an airline reservation system are, okay, I got to scale this thing. So if you scale it vertically, that's a huge cost function. So, at that time, technologies like Golden Gate sort of solved it rather elegantly by saying, well, let's go ahead and sort of create one master and, and slaves in sort of a replication architecture from a logical perspective to sort of separate out our writes from our reads. And so they cleverly use that distribution for scale and performance. So that was the idea behind Golden Gate. And, obviously then, as we made that successful, there was a number of interesting problems that emerged during Golden Gate, and that's what led us to Striim and try to address some of the problems that we were facing back in the 2000 to 2010 timeframe.
Yeah, it's like I said, it's really foundational software that really inspired the big data processing products that have come out since then. And if you look into Golden Gate, now it's under Oracle, of course.
Yeah.
And you resumed at Oracle after Golden Gate was acquired there. Now, Golden Gate, if you want to research that, you can go look at the Magic Quadrant and for data integration products, and it's at the top there, and it's widely recognized as sort of a foundational software, like I said, for many of the replication and database processing workloads. And now, which kind of is a good segue into Striim. What inspired you to start Striim? Is it just another Golden Gate, or is it something else?
Yeah, no, that's a great question. And I get that question quite a bit, John. Uh, uh, Obviously, it's not the same thing, right? I think so. If I go back, right, there were two distinct things that we were trying to address that Golden Gate did not address. And that sort of converged with kind of the advent of some of the work coming out from the Hadoop and Spark, the Berkeley guys, AmpLab guys at that time, with this whole approach to big data through parallel paradigms like MapReduce, etc. Right. So one was the focus on not just structured data, but also on semi-structured data or maybe unstructured data. So addressing sort of the breadth of these sources was kind of interesting and important because people were beginning to ask for that. I'll give you an example. Um, so Golden Gate was focused more on database to database stuff, but when people would bring those problems up, like, hey, we also want to like go apply some of these changes onto a non-database. Um, so some of our teams went in and we kind of did something kludgy to make it work, right? But there was a pattern there. And I don't think that that pattern was solved very elegantly there, right? It was more of a Band-Aid add-on, right? And some customers used it, but that was kind of like one idea that, this, you could just generally apply this problem to truly account for the heterogeneity, the structural mismatches, the syntactical mismatches between different systems, right? Databases, NoSQL systems, databases, messaging systems, databases, messaging systems, storage systems. And you can see the gamut of these things, right? And, it's interesting, right? I mean, one of the core drivers behind some of the things we are doing today, with the advent of the AI, mainstream AI, or generative AI era, if you will, right, is the fact that even to enable my AI agents, I need to go in and retrieve information from somewhere and then process it and maybe allow someone to take an automated action on it. So it was important to address the various sources. Okay, so that was one of the problems. The second was there was a lot of databases that were becoming very, very large. So the scale part of it was coming in. And when you have the scale come in, you know, sometimes between, the different points of like a distributed system, let's call that, people, you can call it like, maybe a mesh or maybe just a fabric or however you want to, but fundamentally it's a distributed system with multiple nodes. And if you push one of these nodes super hard in terms of how much traffic is coming through, you're going to build up latency as this data is going to one of the additional points in your distributed ecosystem. So there was an open challenge there, John, which was, there's this lag building up. So what is going on here? And that actually meant something to ultimately to the businesses. So they would say, look, typically we see that, the propagation latency, the message propagation latency or replication latency, however you want to call it, or lag between, two of my systems is maybe a few hundred milliseconds, but it's like 35 minutes right now. Okay. So that means that there's a spike going on. And there was this general problem of how do you go in and literally peek into the spike and observe that and analyze that to figure out what does this really mean to the business. And I think that was where these two, so the part about accounting for kind of the newer sources of data, and then the scale part of it as it started hitting it and these latencies started going up, the ability to observe that and try to explain that necessarily warranted some sort of an interesting engine. And that's where I think so Striim is sort of a Golden Gate plus plus in that sense, right? That it's not just about the data movement piece of it. It's also data movement applied generically, but then on top of that, the ability to go literally having transparency and observability on the moving data to try and make sense out of that, and to try to express declarative queries on that, to try to express any AI automation on that. So we've kind of evolved that system now to this point where you can actually do a lot of smart intelligence as you are dealing with this distributed system, and that's kind of one of a very powerful capabilities here.
So Golden Gate was really change data capture more to solve the 1990s, early 2000s generation of problems, which was replication for heterogeneous database setups, for high availability if you had multiple database nodes that you wanted to keep in sync, which is a great use case and still applied in a lot of areas.
Yeah.
Now, when we look at Striim, change data capture, high speed, low impact change data capture, which is going against the logs, is one of the core features, but it's also natively tied into a stream processor, right? And it's a horizontally scalable stream processing engine.
Yeah.
So what made you look at, CDC? Obviously, Golden Gate didn't do stream processing. It was just, actually, I'll ask you for clarification. Was Golden Gate an in-memory stream processor? How did it actually replicate changes?
Yeah, so Golden Gate, first of all, didn't have any streaming engine within sort of its architecture, right? So the idea there was more, it was a processed, component based, published and distribute and apply type of a architecture, right? So there was like a CDC process that would take the changes and push it onto a queue, and there was another guy who would read the queue and then serve as a client to a database and deliver the changes. In Stream, the architecture is very, very different. You know, so CDC is also a part of it, but not only CDC from databases, but also like we're getting changes from, for example, NoSQL systems like MongoDB and getting it from the ops log, or from Snowflake from their change streams, or using our delta identifying techniques on things like BigQuery and Redshift, and so these are the things that so we are able to universally identify what's changing and move that, right? So that's the extension part of it. But to your point, now within the streaming engine itself that Stream has, we have very high speed in memory constructs that allow data to go over sockets. You don't have to just do that. You could also leverage Kafka as a persistent layer underneath the covers to try and free up the publisher and the subscriber so that they can move at their own speed. So both of those are available within the platform. But I think the big novelty there was the presence of a actual engine, which is the continuous query processor, right? And the continuous query processor is the part, John, I was talking about, the where you can observe the data and you can try to analyze the data. So oftentimes, earlier on, this may be characterized as streaming analytics, right? Where people like, early when Twitter and Google and these guys came in, or when let's say the concept of like Meta was introduced, they would count up things super fast, right? So how do you do that? I mean, that means that you gotta like constantly go in and take your metrics and aggregate them on the fly. You don't have the luxury of pushing them on disks first and then doing it. So that piece of it is where this capability comes in into Stream. And this was, by the way, I mean, our ideas were patented in early 2014, and we got that granted. Flink was invented after that, by the way, right? And at that time, other than Twitter was using Apache Storm, which was like just ridiculously slow. It was like an order of magnitude less than what Stream could do. So what we've done now is made sure that you can express these declarative queries that can be used on the moving data, and you could apply windowing functions there. You could apply interesting agents which allow you to do AI or machine learning on the data that's moving. So in other words, we're we're coming onto this era of hyperautomation, right? Where earlier I need to do things manually. I want to, okay, let me grab data from here, let me push data here. Now, what we are doing is we're opening the world up to this class of applications where the data is moving, and now the system is actually, reacting in an automated way to say, hmm, I think that there's a pattern here. Someone needs to take an action on it. I've taken the human out of that. Now, these are very like interesting ideas and advanced concepts that we are enabling, but they are going to be super interesting with some of these newer patterns we are seeing with agentic AI and hyper automation. That's where you do need truly to observe the data that's moving on the fly in real time, because otherwise you're as stale as the last time you train on some data. And that is kind of game changing in my view.
Absolutely. And, in terms of applications of this, I look at ABC's Good Morning America did this great segment on how UPS is using AI to battle porch pirates, people who basically steal packages from your porch. And if it has huge business impact because this is a very obvious issue to consumers who don't want their packages stolen, and they're looking for ways to mitigate the risk there. And UPS has deployed this really amazing next generation cloud-based AI stack, which does include using Stream,
Yeah.
right, to get that operational data into the AI engine. So that's one real world deployment of Stream for AI, and it can also be broadly used for analytics use cases. It can even be used for replication. I'll get into how we use Stream for our own internal workloads. But I wanted to talk to you about what are the larger use cases for tying streaming with AI.
Yeah, so great question, right? So, and I think we just began to sort of get into that area. So, if you just take a look at AI in general, if we sort of look at its own evolution all the way to now generative AI, and the applications in kind of natural language processing and text summarization and so forth, we introduced AI in Stream from a machine learning perspective very earlier on. And this was, and I think we published some of this work in at one of the VLDBs, I think 2019, I think, or 2018, I forget the year, but where we talked about sort of an online machine learning model that we were keeping fresh and up to date for just predicting what network traffic patterns will be based on the historical and the real time streams that we are seeing, right? So where I see sort of streaming and AI converge is number one, it's AI is only good. Everybody understands this thing, and you've probably heard this like 100 times, that AI is only as good as the data, right? Now, it's remarkable that at Stream, we tend to get a lot of this data from highly accurate and high fidelity systems like databases where we have bothered to curate the data and push that into a knowledge base. So, to a large degree, despite some minor cleansing issues and whatnot, to a large degree, it's serving as the operational tier and it's high quality data. So, we as that data is getting updated in real time, making that data available into an AI model in real time, right? That is one area where this is a very nice convergence and I would say an interesting use case, because it still requires you to do change identification, right? If I am a large retailer, or if I'm a large logistics carrier, when I'm trying to track my shipments and so forth. So as newer things are happening, how do you make sure that an AI model is made aware that things are actually happening around the model, right? So intelligence is not about specifically being stale and dumb, right? Intelligence is about actually being super aware and learning on the fly. An intelligent person is not somebody who can just answer your questions. An intelligent person is also somebody who's taking real time feedback and dynamically going ahead and constantly doing learning. And so that's where I see these worlds kind of converge on, right? That so far a lion's share of the attention has been on, hey, I train the model and I do inference from that model. Now, slowly we are beginning to see through the, maybe a retrieval augmented generation pattern that, hey, the model can actually be enriched perhaps with better contexts, which, typically translates in the form of, vector embeddings and whatnot. So how do you create these vector embeddings so that, your, fabulous new Gen AI application can take advantage of it? Well, it needs to get real time data from somewhere to create that vector. That's where I see the convergence of the kind of the streaming capabilities and the AI capabilities. And in fact, we've introduced our own agents into the Stream platform where we are doing some fascinating things, like which traditionally have been super hard to do, like identifying any leaks in personally identifiable information, for example. Or is there any sensitive data that is going through my pipeline? And not just databases. It could be, it could be a communication tool like Slack, right? And if I cut and paste something in a Slack channel, who's monitoring whether or not I'm allowed to share this with whoever is on that channel? So you want to scrub these things. And I think as we go through as AI unfolds itself, some of these things about, number one, the ability to do real-time ingestion into the model, the ability to actually make real-time data available to the model for the purposes of RAG, for the purposes of fidelity, for the purposes of trust. I think these are the kinds of things where I see Stream and AI kind of converge.
Yeah, and especially for these inference time workloads, I'll just ask you a blunt question, which is, okay, I have all these AI agents. Why don't they just
Yeah.
go go talk to my database or go into my Slack and hit the API there, or go fetch the data from the source at the time it's needed versus replicating the data into the model?
Yeah, no, and that's a great question, right? And I think that in maybe some workloads, that is absolutely the right thing to do. However, I think what we see really in enterprises and in our customer base is they're not leaning on one system, right? Typically, these systems evolve. And that's kind of what I was saying. Typically, the pattern is that I have this interesting network of distributed nodes, and there are things that are happening in this distributed network at different, it's like a time space thing almost, right? So if something happens, the interesting thing is, how do you get notified? In your example, the database of records, how does that get notified that something else externally has changed, but the model needs to be aware of it? So that's where change identification is a problem. And the second part is, you can't keep the agent can't is operating on some training model that was trained as of a certain time. So how do you then make your inference smarter? How do you give it advantages to say that, hey, if something is changed, and if you're running maybe a vector search on this agent is running some sort of vector search here, right? Whatever it is, how do you get the most recent representation of that semantic information to the actual the vector search, so that you can actually further qualify your specific response, and now you're fine tuned on the fly? So that, John, I think is where I would say I would draw the line, right? That obviously we complement some of this fascinating work that others like OpenAI or Gemini and Cohere, all these guys are doing, right? So their strength comes in where they're saying, hey, look, we have a zoo or a garden of these models. So depending on which multimodal aspect you're talking about, image or audio or video, they're focused on saying, select this model. What we're saying is that, hey, as events are moving, as real-time transactions are occurring in the real world, there are changes there that need to interact with the model itself. And this model, if it's only operating in isolation, is not going to have the most recent change information available, either in its raw form or in its vector form. That's what I think Stream is adding to that mix.
Absolutely. And so many of the fundamentals and best practices of data management apply in AI as well. And, it's unpredictable how many AI agents and workloads can be running at the same time. And are you really going to let them go pull your production operational system? This is the same question of, like, why do we have OLAP? Earlier in the season, we had Andy Pavlo from CMU, from Carnegie Mellon, and I asked him the same question. And, basically, I mean, we wouldn't have engines like Snowflake and Databricks, which looked at the analytics platforms and really centralized data for BI and data science purposes, right there. And the operational teams are running the database, and your analytics teams are generally running your data warehouse. Then you'll have AI teams, whether they fall under engineering or analytics. I think that's every company's own adventure that they need to figure out. But they'll still need their own data store that has fresh, curated, uh, uh, governed data specifically for AI workloads. And just like the analytics team that might have hundreds to thousands of analysts and data scientists who can be running workloads at any time, they don't want to hit the operational database. They want to work on their data lake.
Yeah.
AI agents will very practically run into the same issues where you'll have any number of AI agents and they'll need their own sort of layer of indirection, their own kind of buffer zone to use as the context window for their data. So absolutely, replication and streaming data into the models absolutely makes sense there. And I want to bring this back to some of the work we did around data governance for AI specifically. In the latest release of Stream, what we call the fifth generation of Stream.
Yeah, so and I'm really excited about some of the work that we have done because it is very novel. To my knowledge, I mean, where, John? We're in February now of 2025, right? So to my knowledge, I don't think anybody else is doing this yet. So the idea was that, hey, when I'm setting up my data pipelines, could I make sure that I'm using some of these foundational models to identify things that are private and sensitive? And so we've actually applied the model. So we introduced two new agents into InStream 5.0, which is our fifth generation, as you said. One of them is called a Sherlock agent, and another is a Sentinel agent. And we thought about it, you know, very thoroughly and from a holistic perspective. So there's a design time part of this thing where before I'm setting my pipelines, I want to just know, am I going to encounter any sensitive data? So we design one specific agent for that purpose to say, go investigate, do a bunch of snooping around on my systems where my events are going to come from, and tell me whether I'm going to encounter any sensitive data. And that actually, again, we've optimized it. We've kind of, made sure that we have the right frequency and sampling there so we don't disrupt the external world. So that's kind of one powerful capability there before you actually go in and start moving the data. Now, the second part of it is Sentinel. And so Sentinel is like this incredible agent. And it's kind of, literally sits in and, reminds me of some of these like sci-fi movies where, you can peek into like a bus and look at the people and say, okay, that's John right there. Um, and so Sentinel actually is running, a lot of the sensitive data detection on the various attributes, and then, just taking a look at that, and for governance reasons, identifying that something might be a social security number, or it might be a Singaporean national identity number, or it could be, just an address somewhere in Tunisia. So, and it's very accurate and it's very powerful, but we didn't stop there. So once you identify it, the question is, for governance, what do you do next with it? And that's where there's a gamut of policies and actions that we have added into this thing. So as a policy, I can in stream go in and say, deal with this sensitive information categorically by either masking the entire thing, or masking a portion of it, or encrypting it, or tagging it. And I think tagging is a very powerful technique. I think that in a few years from now, this is going to become mainstream because tagging has a lot to do with this trusting in AI, right? The fact that I'm able to go in and tag a piece of data using my model to give you more metadata around it, so that, right from, you know, uh, understanding maybe what is the lineage of this data? Can I trust it? Did my observers, like all these agents that are observing it, what did they think about this at the time that it was moving from one location to another, or one node to another? So you can see that, as this is evolving, we are putting in these breadcrumbs, which kind of brings me all the way down to the top of recovery, right? That there's a pattern here from a logging perspective that, if I want to evolve something, I need to keep track of stuff in an efficient way. And I think the same concepts that we learned all the way back from saying, hey, there are these changes or there's these breadcrumbs that I need to tie into events so that I can, either for backup reasons, replication reasons, heterogeneous logical replication reasons, stream processing reasons, and now AI reasons, go ahead and leverage some of these artifacts. So really excited about these capabilities in Stream 5.0.
Yeah, absolutely. And this has been discussed even with other guests here on what's new in data, but the quality of the data influences the quality of the AI.
Absolutely.
right? So having inaccurate data that doesn't make sense, right? This will all lead to negative outcomes with AI and hallucination and just things that just generally don't work and make people say, okay, this is another form of AI slop. No one's going to invest in it. Then the other side of it is making sure that it's governed, right? Making sure you're not sending customers social security numbers and things like that into a workload that, becomes a customer facing chat experience. And hey, me, John, I can look up Alok's social security number by asking it. I mean, these are the type of data leakage that can realistically happen, right?
Absolutely. And it happens all the time, John. Like we talk to customers all the time, and they're like, "Oh yeah, so such and such happened," and it's always post facto. And I always tell people that it's surprising to me the cost factor that people pay in a reactive manner rather than just proactively thinking about this as a preventable problem, right? You may have like 100 security products out there, but you need to have a horizontal view across these things to see that the corners where these things are glued to each other, right? Is there a correlation happening there? Is my surface area of attack being tracked in real time? And those are some of the interesting things that I do think that now with these security agents and so forth on these moving data, I think we're gonna venture into that area soon as well.
Yeah, absolutely. And there's tons of use cases for streaming. And for instance, we have our serverless stream developer platform where anyone can go in and try these features for retrieval augmented generation, vector embeddings, replication, where we're basically offering it as a multi-node stream cluster, right? And that's just in and of itself a use case of Stream, offering stream cluster as a service, data streaming as a service. And then even in the back end, the way we ensure high availability in the case of regional or availability zone outages, we're actually using Stream to replicate to a backup database and then restarting the cluster with the same metadata. Then on top of that, we say, okay, well, I mean, what do people actually get out of these streaming pipelines? How do we, what are the number of weekly active users? How far do they get into the pipelines? Again, that's another use case of Stream because we copy that data into our analytical warehouse or we use that for reporting. So streaming is really, a lot of people have this misconception that streaming's super complicated, but then I actually look at all the streaming, guides and implementation. It's like, oh, well, you got to set up your open source CDC platform. You hook that up to your Kafka cluster. You got to set up, your Zookeeper. Now it's Craft, right? And you got to run this Kafka cluster. You have to think about topics and brokers and the replication factor and the cost implications of that. And then finally, once you get into interfacing with analytical systems and AI systems, okay, now you have to think about, okay, what does each system actually do with an event, and what is the payload of that event, and how is it actionable, right? So that in itself is an engineering problem. Yep. But I think especially with the next generation of work, especially getting the business value, the time to value as fast as possible, just having a product that abstracts that for you end to end makes it a lot simpler as a managed service or something you can deploy in your environment. So, that's super exciting for the work you're doing here. But I also want to back up to just, we were having a really fun conversation about databases. What's just a general fun fact about databases that most people don't know?
Good question. Well, I mean, I can talk about one specific database that I worked on, and I think it's still true, but I think maybe a lot of people may not know that you could configure like maybe an kind of an odd size block size in a database. So usually you think like, okay, well, maybe 2K or 4K or 8K or 16K or 64K, 32K. But I think it's true that you could probably have it as a multiple of 512 bytes. So you could probably get away with a 3.5 K block size. I don't know why you would do that, but I think it's a fun fact. So I think that's used to be true, at least by the time that I was dealing with it, but I'm not sure if that's plugged in now or not.
Yeah, and there's a lot of interesting, especially when you get into the bare metal aspect of databases and how databases kind of compete with the operating system for resources, and even the way the database assumes that certain resources might be available. And for instance, the operating system, if you take an operating systems class, you know that operating systems have their own buffer cache, and then databases on top of that have their own buffer cache implementation, which is a bit of a different approach. I don't know if that's something that you
Yeah.
could comment on.
Yeah, well, I mean, I think when, so I don't want to get into any proprietary stuff, but, there are ways in which we could just completely manage the buffer cache directly in the database layer and bypass that completely. So you can actually, even in interfaces, let's say when I'm just doing I/O to a disk, right? I can just bypass the operating system. I can indicate to the operating system, I don't want this cached, right? So then it doesn't store, and now you don't have to pay the penalty of kind of a multi-layer caching scheme there, where the database itself will directly just say, I'll manage this thing. So at least in the advanced databases in the world, that should be just de facto in my view.
But it's
As a,
not.
I don't think everybody does that.
Are there any open source databases you can kind of?
I'm honestly not. I haven't caught up, John. I've been busy with Striim, so I haven't caught up what maybe some of the open source guys have been doing lately or not. But I mean it's 2025. I think it should be something. Now, whether or not everybody leverages that or not is a separate question. But I think the in code, I think it's doable. I think in most of the popular like Postgres for sure, I think you can do that.
Yeah, absolutely. And you also had a fun project with running Oracle on the Mac.
Oh, yeah, that's probably like one of my biggest regrets, by the way. Well, let me clarify that. So back in the day, we ended up doing this project, so which kind of allowed some objects from like one Oracle database to be kind of plugged into another Oracle database. Right. So for example, if my database was on, let's say, IBM AIX as an operating system, um, I could just you know copy the files, right, database files, and then plug it into like a Windows or a Mac based okay, let's not talk about Mac, just the Windows based database, right? Prior to that, you had to, John, go through and do this massive thing where you'd like unload all the data and reload it to the SQL engine. So the problem there was that it was kind of dependent on the size of the data. So if you had 100 gigs versus a terabyte, right, all of a sudden it's 10 times the penalty that you're paying. But if you're at disk copy speeds, you could do this much faster, right? Okay. So we wanted to do that. This is when I was still in Oracle. I think it was in Oracle 8 or 9. I forget exactly the version right now. So it was called cross-platform transportable table spaces. And as part of that, we needed to figure out, okay, what are the various platforms where you could go take this to? And Oracle had a lot of ports at that time, right? It used to run on like Siemens and HPUX and Mac and all kinds of flavors of like AT&T SVR5. There's a bunch of operating systems that DAC, VMS. So we had to manage that, make sure that we kind of restricted the number of platforms that we wanted to port the Oracle database on. And as part of that, we did some analysis. And I guess maybe one of the regrets is that Oracle used to have a port on Mac OS, and we nuked it at that time. Mac OS X didn't make it to that list because this was kind of like Apple was kind of going downhill at that time. And
90s, right before Steve Jobs rejoined.
yeah. So it was never considered like we were like, who would run an Oracle database on a Mac? But now let me tell you, like I love the Mac, and I'm a developer on the Mac, and I wish I could just run the Oracle database on my own Mac. So that's one of the regrets that I have. So that's a fun fact about kind of the porting aspect of Mac OS XY. So now there's no Oracle port on Mac OS.
Oh wow, your team didn't want to think different at the time. I
I thought we were thinking differently. I thought we were like, who's going to run the database? Like, it's not a serious operating system where you'd want to run an Oracle database on. But I mean, ultimately, I think we've kind of converged towards kind of the Linux flavors anyway. So I think in retrospect,
yeah, Dockerize Oracle on a Mac
Mac is a
is totally acceptable now. And
exactly.
yeah, but Oracle famously has over 25 million lines of code, and porting to every operating system at the level that Oracle had to support it must have been a massive undertaking. So of course, it made sense that you had to prioritize the platforms that people were realistically deploying on at scale.
Yeah, and then you got to test these combinations, and there were genuinely some ports that were. Well, I don't want to get into anything that's not documented publicly, but let me just say that Um, some of the platforms kind of, they have like this um, sort of a header which is special, and not everybody had that header. So imagine that, like if you're the database manager, right? As in like code, and someone says go start up the database, you got to go examine all these files and the headers to say, do these belong to me? Is this kosher? This is kind of like the dance between the headers, that are metadata that I was talking about earlier, right? Is this safe for me to open? And if you didn't have that header, it was tough to know, is this corrupted, or is it actually, something that it is coming in from some other platform that someone has shipped to me. In other words, if you're doing this trick to plug this kind of this data from one database into another, I have to ship it, right? So this database manager, now when it opens that file, it needs to recognize what am I dealing with. And because of this non-standard, kind of, we used to call this the kind of block zero, or the OS block header. Not everybody had it, so that made it complicated. So that's why we had to kind of trim down and make sure that the platform list was kind of manageable, and we didn't have to have this, sort of, N by M problem, right? We kind of restricted it to just a small set of ports. I think we brought it down to maybe 18 or 20. I don't even know if there's 18 ports anymore. It's probably a smaller number.
Yeah, it definitely database development is a fascinating area. It's becoming more popular than ever. And like I said, we had Andy Pavlo earlier in the season, and Mark Brooker from AWS, and it's incredible to see that it has almost a cult following, its own audience. Thousands of people follow the trends in database development, and just go in, and I think ultimately a lot of people ask, well, now I know how a database is built. Why don't I just build my own? But then you look at real world implementations of databases and see, okay, Oracle's 25 million lines of code, and it's not slowing down. I mean, Larry Ellison was just up on stage with Sam Altman and our president, talking about the $500 billion that's going to be invested there, right? So, and then you look at some of the popular open source databases like MySQL and Postgres, and then even the growing NoSQL object stores like MongoDB and things along those lines. So, there's a lot of work out there. There's a lot of opportunities to stand on the shoulders of giants. So especially for data engineers who want to really do impactful work or that relates to an operational database, or whether they're scaling it or trying to get data out of the database for analytics and AI use cases, it's really important to be aware of these types of fundamentals.
Absolutely. And you're right, John. Like, I think, a lot of the people have taken a stab at kind of writing a database from scratch. It can be done, but I think the evolution of it, and, addressing sort of a generic class of workloads, that's not an easy problem. Like, you mentioned Oracle's lines of code, right? I mean, if you take a look at some of the more recent stuff, right, right from model extensions to vector representations, trying to do like open neural network extensibility through PL/SQL functions, and there's a lot of work in that, right? So when you go in and start embarking on some of these things, you know in a narrow domain, you could always build like maybe something that's super specialized. And I think we've seen that, right? I mean, a bunch of folks have done that. But to try to sort of sustain it across hybrid workloads, but still keep up with sort of the cutting edge technology, it requires a lot of R&D budget for that. Requires like a proper investment in that area. And I think that's where you'll fall behind very rapidly, because you don't know where to focus on at that point. And I think that's where I do think that it's not an easy problem. But if you want to restrict it to a specialized domain, yeah, that'd be fun to build another database, I guess.
Okay, that's our next project. Let's do it.
Okay, John.
I mean,
Sounds good.
I mean, a lot of people ask us, is Stream a database? Because we have a SQL engine. You could technically store data,
Yeah.
but we've been always pretty firm in our stance that it's not a database.
Yeah. I mean, and that's deliberately so, right? Because I don't think that the whole idea here was that, there's data in motion and there's data at rest. And combining these two things, there's been a lot of architectures proposed, but I don't think anyone's cleanly solved that problem, in my view, at least. And I think so. So we're definitely not a database. However, there is a storage tier in Stream, And in fact, by default, we back it up with the distributed Elasticsearch cluster.
Yeah, my first project here at Striim, by the way. So just fun
Yeah,
fact.
I remember
Yeah.
that. And so so you could actually build these fast aggregates, right? Let's say over moving data. So let's say that I have store sales being reported from every single I don't know, Lululemon store or something. I don't know if I'm allowed to talk about specific entities, but that's an example. You could actually see, like, hey, what are the 15-minute sales per store. So you can partition by the store ID, and you can actually go ahead and use the Striim store to go and push this into Elasticsearch, and now it gets indexed for you automatically. And you can actually build an actual application directly, right, on Striim now, right? So that's absolutely possible. In fact, because Elasticsearch also has capabilities to do things like vector search. There's a possibility from an AI workload aspect for us, but I don't want to speak about futures in this thing right now. But that's an active area of R&D for Striim, trying to get us into that realm where you could just take a brand new agent, and you could look at it as an automation problem between different data pipelines, and there's the pieces external to Striim where agents can go in and grab the data and then process it. But then there's another agent that's actually leveraging from an application perspective directly on the Striim platform itself, and doing things like maybe having the RAG pattern within that application directly. And so that's an area that we want to definitely get into in the future.
Yeah, absolutely. And my take on that is, a lot of companies are doing CDC today, but the compromises they made in the process suggests to me that it's not a solved problem for analytics or AI. Because you have these teams that say, yeah, we have this CDC thing running, but we don't care about latency. We ship reports out and we're okay with 24 hours or even 2 hours. And that's fine. It's not our role to tell everybody that real time is always required. It's honestly not even required if you're a Striim customer. We have customers that run reports at an hourly
Sure.
basis. And then you look at other compromises made, like, okay, I mean, how do you know that your reports are accurate with transactionally consistent data? That's a dicey question, because most analytics teams don't even want to touch that area, because once you even raise the question, it kind of opens up a can of worms that they're not ready to surface with their own management. So usually we hear about the other way around from a data executive or an AI executive or a CIO, who definitely wants to be able to go to the CEO with confidence. And a CEO, first thing they will say is that, well, is this report real time? Can I trust it? Can we actually make insights from it? Right? So my message on just your comment about the storage tier and using AI to collect automatic insights is that this is the next leap that teams will have to make with change data capture and replication and streaming in general, to make sure that they have fast time to value, fast time to business insights that's enabled by AI. And like we said, we have really awesome large scale customers like UPS who have done great work here, and we're excited to work with hundreds of other customers that are doing this to the thousands in the future. And it's really an exciting time.
Yeah, absolutely. I think those are great points, right? I mean, I think I hear the term CDC kind of casually being thrown around a lot, and there's an unusual hardship, right, when you're trying to support change data capture. And one of the very naive approaches that I see people take is assuming that somehow I'm going to have the entire record available in my change stream, right? If I have a wide record with 318 attributes, for example, and I go update only one of those attributes, right? A lot of the frameworks make the assumption that, sure, in my change stream, I'm going to have all 318 attributes available. Now, okay, and that's the part that you're saying that people make kind of compromises or assumptions. If you can make that assumption, okay, you can live with it. But real world applications don't behave like that, right? That's a lot of overhead. It's inefficient, right? And it involves logging on the system that is generating that change and makes assumptions about that system. That's not true in the real world.
So how Stream solve that?
Well, Stream supports compressed updates. So in many of the sources, right, we can actually just take an update with just the key and the before after image, and basically a bitmap that tells me what columns have changed, and we carry that information along with the metadata, and we react to that. And that's where the problem becomes interesting, because if you, like, to your point, John, now if you take a look at sort of a data engineer, right, in the first case, right, where they had the entire record, okay, as a client, I can go push this entire thing into my data lake. But if I have partial images coming in from a very mission critical application, I'm lost. I have no idea what to do with this thing now, right? You're not conforming to this. And even with open formats now that are coming in to represent logical change records, it's not an easy problem. You got to manage the schema. You have to do conversions. There are in within the decision making pipeline, you want to say that, like we talked about, I want to maybe mask something, and these are the kinds of things in for as we are moving towards event driven, especially real world event driven applications, that systems have to pay attention to. So I think, I always sort of think that people who think this is just a CDC problem are looking at the world sort of in a very very narrow domain. I think that problem was solved probably 35 years ago, in my view. Right? You could write a trigger and do change data capture, and now I have everything. But it begs the question, like, okay, are the operators of that system going to allow me to write triggers? And if they say no, all of a sudden all bets are off. So I think those are the kinds of things that move sort of this argument from a developer oriented mindset to an enterprise oriented mindset. And I think that the choice is really, you know up to you, right? Do you want to spend your time with the stuff that you really know about and are excel at, or do you want to get into the nitty gritty of saying that, hey, I want to get into some of the core logging concepts, transactional concepts for consistency reasons, etc., or the accurate aspects that you talked about? Who's going to deal with this? Who's going to deal with the event processing guarantees? That's where the fun actually starts. And I don't think that a lot of teams are very equipped, especially if they're not database guys, especially if they're application level guys. It's a tough problem to crack, right? Very few get it right, in my view.
Absolutely. And there's so much work to be done right now in really deploying next gen analytics and AI use cases. I think they go hand in hand, and as we're seeing more teams adopt AI in real world use cases, it does seem like a function of a data team, right? Because it's not quite software engineering, it's not quite a reporting or business intelligence role, but it is the team that's sort of bringing in both operational and business systems, marketing systems, CRMs, ERPs, that the internal teams use, and then the customer facing systems, and figuring out how do we really make production applications out of this. So really allowing you to innovate there and build IP for your company that brings the value and shows the ROI. We like I said, we work with some incredible teams there. There's no debating, like we talk about UPS because it's public, and it's so successful they went on Good Morning America.
Yeah.
It was a cool segment. So there's just so much fun work to do. And I think it's an awesome time to be in data. And it's an awesome time to be working with these products, and it's I can't remember this level of excitement, and since the first iOS app store blew up, and we saw the early days of things like Uber and all the various mobile applications that blew up, and Instagram and whatnot. Now we have this kind of new wave, generational platform shift into AI. So
Absolutely. It absolutely feels like it's just a brand new world. And I absolutely share your excitement and enthusiasm there. And on to sort of, I think each year is going to show something very, very different. And I'm pretty excited to see what's there. And we have some great things to help, really the world with some of the cool, novel things that we're introducing in the Stream platform.
yeah, absolutely, and we're super excited about that. Uh, Alok Pareek, co-founder of Striim. You used to run data integration products at Oracle. You were CTO of Golden Gate, and then you worked on Oracle logging system before. What's your advice to folks getting into the industry?
Oh, wow. Well, my sense is that a you know make sure that you understand the value of abstraction. um, you know, Whoever's coming in, I think we're going to observe a shift in terms of how we are writing code, how we are putting together different types of tasks, how reasoning is morphing. And so I think, I would say pay attention to sort of what is the abstraction around this. And what I mean by that is there's a way in which these new, AI based, you know workflows, AI based automation, AI based agents, they're going to radically change how systems and humans and processes evolve. And having a good understanding of that and being at ease with that. So do as much as possible to kind of get comfortable with it and adopt it in your daily life. I think that's really, and I myself don't have, like, the magical answer, right? But on a day to day basis, that's what I do, right? Just
Yeah.
if somebody comes in and says, "Hey, here's a way in which AI is going to change this," um, I'm not afraid of that, right? It's another powerful way to incorporate that towards what I truly believe is the highest form of intelligence, and that's human intelligence.
Absolutely, and I wanted to ask you that because you're an expert in your area, but you're still. I mean, I see it every day. You're still adopting the latest and greatest. I want to call it personal life hacks and ways to be more productive and efficient and really moving things forward. So thank you for answering that question, and thanks for doing this episode of What's New in Data. It was super fun. Love talking about databases. It's always a good time.
Absolutely, John. It was a pleasure and great questions, and I love being on. I've been wanting to come here for a while, so this was fantastic. And say hi to Andy too if you're doing. I know Andy well, and hopefully we get to do one of these things again in the future.
Yeah, absolutely. We'll have to do it again soon. And thank you
Great.
for all the listeners for tuning in.